Hello. Today I will explain how to take the first derivative of a function using several different methods. But first, what is a derivative? It's simply the instantaneous rate of change, although you may hear it referred to as the slope of a tangent line or the limit of a difference quotient. Before we begin, let's go over the notation of a derivative. So for a function labeled f of x, the notation will look like this: f derivative of x. For a function labeled y, the notation will be labeled y with the derivative sign, or simply dy over dx. Now that we've gone over the basic definition and notation, let's begin. The first rule I will show you is the constant rule. This rule is very easy. The constant rule is that the derivative of a constant is always 0. Let's look at an example for clarification. So if we're given y equals 6, the derivative would equal 0. See? Calculus is easy. Just remember that the derivative of a constant is always 0. The second rule I will show you is the power rule. This rule states that if we have x to any power, the derivative is equal to that power times x with the power minus 1. Now let's do an example. If we have x to the fourth power, the derivative would be 4x cubed, because the power goes up front and the power is reduced by 1. So now that we've mastered the power rule, let's move on to something a bit harder. The next rule I will go over is the sum or difference rule. It says that if a function is equal to u plus v or u minus v, you simply take the derivative of u and add or subtract it to the derivative of v. Now I'll show you an example. If a function is equal to x squared plus x, you'd first take the derivative of x squared, which is 2x, and then you add or subtract it to the derivative of x, which is 1. Now that I've gone over the sum or difference rule, I'll show you the product rule. The next rule is the product rule. This rule is the first function multiplied times the derivative of the second function, plus the second function multiplied times the derivative of the first function. Or, to help you remember this, you can think of it as 1 d2 plus 2 d1. Now let's do a problem with the product rule. If the function is 3x cubed times 2x squared, the derivative would be the first function, which is 3x cubed, multiplied times the derivative of the second function, which is 4x, added to the second function, which is 2x squared, multiplied times the derivative of the first function, which is 9x squared. And that's the derivative using the product rule. Finally, I'm going to show you the quotient rule. The quotient rule says that the derivative of u divided by v is v times the derivative of u minus u times the derivative of v all divided by v squared. Or if you think of u as high and v as low, it's low d high minus high d low all over low. Now I'll show you an example. If we're given the function 3x plus 5 divided by 5x minus 3, the derivative would be low, which is 5x minus 3, times the derivative of high, which is 3, minus high, which is 3x plus 5, times the derivative of low, which is 5, all divided by low, which is 5x minus 3 squared. And that finished product should look like this. And that's how you use the quotient rule. Thank you for watching today, and I hope you have a better understanding of what a derivative is and how to use the constant rule, the power rule, the sum or difference rule, the product rule, and the quotient rule.